All right, this podcast is over ionic and covalent bonding notes. Okay, first thing, we need to make sure that we are familiar with metals and nonmetals on the periodic table. So when you look at the periodic table, looking at what I have here, you will notice that our metals are from here over. Okay, so all of our metals are on the left side of the periodic table, while the nonmetals are over here on this side. So looking at your periodic table that you have color-coded, it's going to be very beneficial to make sure that you do have those nonmetals and metals identified. Okay, so for example, let's look at some of the nonmetals. Some of the nonmetals include, don't forget hydrogen up in the left-hand corner. We have sulfur and oxygen, carbon, nitrogen, so bromine. So you kind of get the idea. Now, metals, we have sodium, magnesium, calcium, and lithium. For now, we're going to be working with the elements that are in groups 1A through 8A. We're not going to worry about the transition metals at all. Okay, so with ionic and covalent bonding, it's important to know that nonmetals like to take electrons from metals, or they like to share with other nonmetals. Now, on the other hand, metals like to give away electrons. Okay, so they're not real big on sharing their electrons. Okay, when I mean sharing or giving away, I'm talking about their valence electrons, those electrons that are in the outside shell. Okay, so, the reason why we're doing this is because of the octet rule. Okay, the octet rule is the rule that states that these valence electrons have a full outer shell. So we have 8 in this outside shell, which means it's a happy atom. Okay, this leads us into the two different types of bonds. Okay, we have an ionic bond. An ionic bond is usually a metal with a nonmetal. A metal with a nonmetal. And with an ionic bond, the electrons are transferred. Electrons are transferred. And also, once they start transferring electrons, they're starting to lose electrons or gaining electrons. So remember, electrons are negatively charged. So if you're giving away a negative charge, your charge is changing. So each element has a charge. And always remember, opposite charges attract. Opposite charges attract. Okay, now with a covalent bond, just slightly different. A covalent bond is between two nonmetals. And in a covalent bond, they share electrons. All right, so the key here is to know the main difference is we have electrons transferred in an ionic bond. Electrons are shared in a covalent bond. Okay, I'm going to do an example of each for you. All right, let's start off with ionic bond. Now remember, I put up at the top the key things. An ionic bond forms between metals and nonmetals. So we're going to draw the Lewis structure for each element in a box on the left, and then in the box on the right, we're going to show how they bond. Okay, so the first thing, we need to look at the periodic table. Okay, so looking at the periodic table, we need to find sodium. So looking at what I have up here, sodium is located right there. Sodium is found in group 1A, therefore sodium has one valence electron. So if I would put the Lewis structure for sodium, I'm going to show that there's only one dot. Okay, again, let's find chlorine. Looking at chlorine on the periodic table, chlorine you'll find in group 7A. So chlorine has 7 valence electrons. So we're going to put 7 dots for the Lewis structure. 1, 2, 3, 4, 5, 6, 7. Okay, so now after the bonding, remember with ionic bonds, they're going to transfer their electrons. Okay, so looking at sodium has 1 electron, chlorine has 7 electrons, and remember a happy bond is 8 valence electrons. Okay, so if we take this 1 electron, helps if you had colored pencils, put these in different colors, and we transfer that 1 electron to chlorine, we're going to show that chlorine is then going to have 8 electrons. Okay, so again, I'm going to take that 1 electron from sodium, and because sodium is losing a negative charge, so it lost, sorry, that's not writing very well, it lost 1 electron, which is a negative charge, because it lost that 1 electron, it now becomes positive. Okay, because remember the number of protons equals the number of electrons, and so therefore it's neutral. However, if it loses a negative charge, now it has 1 more proton than it does electrons, so it has that positive. Okay, now chlorine is gaining a negative charge, so it gains 1 electron, and because it's gaining 1 electron, it now has a negative charge. So I'm using the little subscript here of positive for sodium and a negative for chlorine. When I tend to write the final compound, though, I would just write NaCl. Okay, and remember, only the first letter gets capitalized. All right, now on covalent bonds. Covalent bonds, they are sharing their electrons. It is a bond between a nonmetal and another nonmetal. They are sharing. We still have to do the Lewis structure, so we're going to show how to do this. So the first thing we need to do is draw the Lewis structures of each atom. So again, on hydrogen, hydrogen has 1 valence electron because it's found in group 1A. Chlorine has 7. Okay, again, these are both nonmetals. So I'm showing my 7 here. And this time, instead of transferring the electron, they are going to share it. Okay, so I'm going to show this by putting chlorine up here. 1, 2, 3, 4, 5, 6, 7. Now, in a different color, I'm going to put hydrogen. Let's do green this time. Okay, and hydrogen has 1 valence electron. All right, so if you notice, I kind of lined them up and paired them up here. So the 1 open space that chlorine has, I put the 1 electron that hydrogen had. So they are showing a share. They are going to share that pair of electrons, which is going to make a single bond because they have 1 shared pair. So I would write this compound HCl. Okay? All right, that concludes the podcast for ionic and covalent bonds.